Hi, in this tutorial I'm going to cover setting up SDL 2.0 to run on your iOS devices. I'm also going to cover some of the sort of platform specific issues I ran into when first starting to use SDL on iOS. The first thing you need to do is to make sure you have SDL 2.0. I'm going to download this via libsdl's Mercurial repository. So simply type the command you have on screen into terminal and wait a few minutes. When downloading from the Mercurial repository completes, navigate to the download directory in Finder and in the XCode iOS folder open the SDL XCode project. This project allows you to build SDL 2.0 as an iOS shared library. So first of all, let's make sure it's been built in release mode. I think the default is debug. And to start with, I want to build it for the simulator. Later on, we're going to get back and build it for the device. There is a small issue here that we can deal with, but let's get to that later. So it should build without any problems. And once it's built, in products, that doesn't seem to want to work, so I'm going to just navigate to the correct directory in terminal instead. So in library, developer, Xcode, derived data, you'll have an SDL directory. Its ID might be a bit different, so my exact path will differ slightly from yours. Then in bills, products, we have, I'm going to remove all of that just to ensure I am building the correct version. Great, so there's the release for the simulator, and there's our shared library. I'm going to copy this to my desktop. I'm going to rename it slightly to libsdl2 sim for simulator. Right, so there's our shared library. So again, back in your SDL download directory in the Xcode iOS, there's a template folder. So this is a very easy way to start. So I'm going to copy this rather than modifying the default one, because I may want to use that for another project later on. And in here we have the skeleton of an iOS application that will use SDL 2.0. So let's open the project. We have to do a tiny bit of housekeeping before we start. None of these paths will match the default, so I'm just going to delete all the content and then create a folder structure to match. And I'm going to copy the SDL sim into the lib folder, and just for ease, rather than navigating to where they actually are, I'm going to copy all the header files into the SDL include directory. So now that that's done, let's add them into the project. Okay, so it's automatically selecting the correct directory based on its hierarchy. And rather than using the default source, I'm going to copy in some of my own source because I'm more interested in setting up SDL 2.0 so that we can use OpenGL ourselves rather than using the SDL renderer. So I'm going to quickly copy this. This source should be available in a link in the description. Pretty much all we're doing is initializing the video, creating a window, initializing an OpenGL context, and then polling on some events. And when we're finished, we're deleting the GL context and destroying the window. And we're having some problems here with auto. I think that might just be because the main file is a C file rather than a CPP file. So now if we build this, let's quickly change that for iPad. I want to make sure that the framework is SDL framework is being included. Yep, there it is. So let's run it. Okay, so our app is working because that's the default loading screen. And that's it, because the app isn't currently doing anything. So let's make it do something a bit more exciting than displaying the default image. Oh, well, actually, first of all, I'm going to cover something else quickly. You can see here that the project name is project name. That's not really what we need. So if you highlight on the project here in the navigation pane, you can see over here you can modify the name. Just pretty much confirm everything XCode asks you to do, and now the project name has changed. And this scheme we're using, it doesn't really matter if it stays as it is, but it is pretty ugly to be called project name. So if you add a new one, it'll add it to the correct name, delete project name, and done. So if we look at our simulator, let's make this a bit bigger. You can see that the application was called what the project name was. So delete that one. And let's run it again. Okay, so it looks the same, but if we go back home, we can see that it now has the application name that we gave it. So now let's make our application do some very basic OpenGL processing. The header files you want to add for OpenGL ES2 on iOS are, as you can see there. And as per my other tutorials on SDL, I'm just going to make this application update the screen with a random color every frame. Okay, so that was pretty easy. In my other SDL tutorials, I also cover how to use C++11. In iOS, this is a no-brainer. It's already supported by default. So here I am creating a unique pointer to my graphics class. And in here, I just call so that was pretty easy. Let's ensure it works. Another thing you might want to do is to change the default icon, or the default image and the app icon in your resources directory. If you show them in the Finder, you can see that there's the default.png and icon.png. I'm going to replace them with my own icons. Okay, you quickly saw there, it flashed up on screen that it was using my default screen, and there it is using my app icon. So that's pretty much SDL 2.0 with OpenGL ES2 and C++11 working on iOS. It's really simple. So there's a couple of iOS things I want to cover. First of all is that SDL 2.0 has a specific way for iOS to do rendering. When you write a standard iOS application, it does all its rendering on an event, and that's the way it likes to do it. It's the system doesn't like just sort of random screen update happening. So SDL 2.0 has support for doing your rendering based on the iOS render event. So I'm going to create a function like this. It's just a void function that takes a void parameter. That parameter is what I'm going to pass to the function. As you can see, I'm casting the void parameter as a graphics pointer. So in my code, when I register this callback, I pass it the instance of my graphics object, and that gets passed down every time this is called. So the function you're going to use is this SDL iPhone set animation callback. The first parameter is the SDL window that the callback applies to. The second parameter is the interval. I think you're always going to have this set as 1. The third parameter is your callback function, as in here, update frame. And the fourth parameter is what's going to be passed to this update frame in this void start parameter. It can be null if you want, but I'm passing my graphics object so that I can call an update on that. And now let's ensure I'm not doing any updating on my main thread. So if we run this, great, so that works, and that should give you a much more fluid render cycle on iOS devices. Another thing that caught me out when starting on iOS is screen orientations. Most games probably don't support multiple orientations. You're either going to play it in portrait or landscape. However, depending on the game, you may want to support the user holding the screen in either of those orientations. But if we run the demo, you can see that we're getting the events in this section down here, and the output you're getting when the user presses. I'm using the mouse to press, but when the screen rotates, we're not getting any events. So it's not currently possible for us to change the viewport parameters in order to render in the full screen. Once I found out how to do this, it sort of made sense, but it wasn't very intuitive at the start. And the way you do it is to create your SDL window, telling it that the window is resizable, and then in your event processing, let's just do it here. You want to check on the SDL window event resized. And this will, my computer's running really slow for some reason. So this will give us the new size of the window in the window data 1 and window data 2 members. So if we run this again, there you can see that the window sizes flip as I rotate the screen. So that will enable you to support multiple orientations. This isn't iPhone specific. I think this exact same logic applies to Android as well. So the next thing I'm going to quickly discuss is these events. I found when I was writing simple demos, the events were very fluid. They came as I interacted with the simulator or with my device. However, when I was running my game, and there was a lot happening, so physics engine and pathfinding and all the rendering, the events didn't seem to come as they happened necessarily. I quite often would be running along, everything running smoothly, and suddenly nothing would happen. And after a number of seconds, a ton of events would pour down the pipeline at the same time. And there is a way around this, which again isn't iPhone specific. I've started to use this logic in all my platforms that I'm using SDL. And you can add an event watch that will intercept the events at an earlier stage than they are by this sort of whole event function that we call in the main event loop. You wouldn't catch every event in this loop, you just sort of catch ones that you want to react to immediately. And in a game that might be player moving, player shooting, anything that will be immediately noticeable if it's not happening. So I'm going to quickly paste in another function here. So here's my event filter. The first parameter is very similar to this parameter in the update frame. It's whatever I want to pass down to this function. And the second parameter is a pointer to the event. In this demonstration, I'm only interested in the finger motion, finger down and finger up. So I need to make sure that when I'm using this event that I register it. So it's registered with this SDL add event watch. The first parameter is the function callback, and the second parameter is the parameter that you want to pass to that function callback. It might be your game object or your player character or something. In this instance, I don't really care. So just to make sure that they're not being registered twice, I'm going to remove the finger motion up and down events from my main loop. And I don't know why my computer is running so slowly. Well, there we go. They are appearing. It's a little bit delayed because of my laptop. What's next? Oh yes. If you're loading resources in your iOS application, one way to do it is to use the SDL RW ops structure. This is a very good structure. It handles all the platform-specific file system stuff under the hood. For example, in iOS, it will find the correct path in your bundle. In Android, it will extract the item from the APK, uncompress it, etc. However, it's quite possible that you will want to use a third-party library, or just don't want to go and update all your code that is already implemented using standard C FileStar or ifstream or something. So you need to know how to get the full path to your assets on your iOS device. So for this, you need to use a bit of Objective-C. So to my source, I'm going to add an Objective-C class. I don't really care what it's subclassed of, but I'm going to call it resource path. I'm going to add it, just as standard folder, and finish. So I'm going to delete all of this. Make sure that you rename this because I'm going to use a standard string, not the implementation. So here's a sort of a objective C++ function that will get your main bundle, and inside that it will get your resource path. So if you call this from wherever you need it, it will give you. Let's actually run it and see what it returns. SDL log. There you can see that when running in the simulator, the resource path is down to the simulator applications, the GUID, and then the SDL to iOS test.app, and then it's in here you'd have /assets/ whatever. Okay, so now we're back to iOS specific stuff. So at the moment we're running on this simulator, so what happens if we want to run on the device? Normally it should be pretty easy. If you were writing your own application that didn't use SDL, you just change between simulator and device, and then you run. So it builds correctly. But when we're linking, we get an error saying that the lib SDL2sim file was built for archive, which is not the architecture being linked, ARM7. Well, when you think about it, that makes sense. When we built for the simulator, we were building for the desktop, essentially, because that's where the simulator runs. However, the actual device has a totally different processor than the desktop, so we need to use a device-built version of SDL 2.0 when we're building to the device. So if we quickly open up the SDL project again and select your device, go to build. So again, back in terminal, if I go back a directory, and there I have a release iPhone OS, and here is my device specific build. So again, I'm going to copy that to my desktop, but give it a different name, so device. So there's our simulator one, and there's our device. So I'm going to copy the device in here, make sure that went right. Okay. And back in our app, I want to remove the simulator library and add the device library. So now if I quickly bring on my mirroring of my iPad, so it runs on the device. However, we now have the same problem that if we try and build this for the simulator, we're going to get the same linking error. If you're only working on one, it's not a problem. But if you want to work on two interchangeably, you don't want to have to be deleting and re-adding libraries every time you want to change between the simulator and the device. So thankfully, there is a way around this. So I'm going to navigate in Terminal to where I have the libraries stored. And I'm going to use a command called lipo that will create universal files. So universal file is I can combine my simulator shared library, my device shared library, and at runtime, well not runtime, sorry, at link time, the correct one is chosen, and the one library will work interchangeably between the device and the simulator. If you're releasing your app to the App Store, you should probably rebuild it using a library that's only for the device, but for development purposes, this is a great tool. So in the directory, again, that has my simulator and my device shared library, I'm going to do my lipo, the two libraries, /create/output, and give it its name. So the standard one is going to be called libsdl2.a. So there we have a third library. So again, let's go back to our project and remove the device shared library. Add the newly created one. So now we're running on the iPad. And that worked. And if we change to simulator, that worked. So that pretty much covers everything I thought might be useful for beginners who want to start using SDL 2.0 on iOS with OpenGL ES 3. OpenGL ES 2. Thank you.